continue one more video, that is electron displacement. In covalent compounds, means covalent bond, displacement means the movement of electrons or shifting of electrons. Here atoms can actually take more than their pair share of electrons even in a covalent bond, which leads to the variety of electron displacement. An electronic displacement occurs when an electron moves towards one side or part of a molecule. This electron displacement are often responsible for the chemical reactivity of the molecules. And some molecules are relative strength. Okay, here stability is, we will discuss stability also. Okay, this electron displacement effects classified into broadly two categories, that is permanent effect, temporary effect. Okay, the movement of electrons or shifting of electrons from one atom to another atom is responsible for the chemical reactivity of the some molecules and the relative inertness of the other molecules. These permanent effects again classified into three types, that is inductive effect, and second one is mesomeric effect, third one is hyperconjugation, temporary effect again classified into one type, that is electromeric effect. What is the inductive effects are here? Inductive effect means simply very easy definition, that is now I am taking here CH3 CH2 CH2 Cl is there. Okay, this electron is called sigma electrons, or simply single covalent bond. Okay, here nothing but here one pair of electrons. These electrons, the shifting of electron from less electronegative atom to more electronegative atom through a sigma bond, or the displacement of an electron from one atom to another atom towards more electronegative atom through a sigma bond is called inductive effect. We will write definition here. What is the definition of inductive effect? Inductive effect. The shifting of electrons or the displacement of electrons, from low electronegative atom to more electronegative atom through sigma bond is called inductive effect. It is denoted by the letter is capital I. For example, now I am taking here in this compound this electron moving toward this side to form what happened, CH3 CH2 here, Cl carrying minus charge, in the CH2 carrying plus charge. This electron moving towards here also carrying positive charge, this electron moving towards carrying positive charge. Simply the displacement of electron towards more electronegative atom side through a sigma bond is called inductive effect, or the transmission of unequal sharing of bonding electron through a chain of atom in a molecule is also called inductive effect. Okay, what is the reference element of inductive effect to hydrogen atom? Okay, the inductive effect of hydrogen is becomes equal to the 0. It is a reference element. And what are the important points of in this inductive effect? It is a permanent effect. In a covalent bond, unlike atoms, electron pair forming in the sigma bond never shared equally. Okay, this effect, this polarization C1 atom and C2 atom is less than the C1Cl. This effect is more in C1 carbon, C2 carbon, but not C3 carbon onwards. Like that, here it is also defined as a polarization of one bond caused by the polarization of adjacent bond, and also it is also called transmission effect. Inductive effect is also called transmission effect, and it is caused by permanent polarization in a molecule. And permanent effect, the displacement of electron takes place due to the difference in electronegativity. Okay, it is due to the difference between the electronegativity atoms. Up to atoms involved in the covalent bond. The electrons never leave their original atomic orbitals. It is always operate through a sigma bond, but not involving in the pi electrons. Only involving in the. This is information about what is the definition. What are the characteristics? First character is it is a permanent effect. It is also called transmission effect. It is depending upon electron negativity difference. Electron negativity difference. It involving only sigma electrons but not pi electrons. Thank you. Next class we will continue classification of inductive effect. Thank you.